Well, welcome to algebra. We are probably watching this together, so it's going to be a little bit different. We've never actually watched a review together, but that way people who are gone today can watch it online, and we can stop it and pause it if we have questions or anything like that. So we're going to look at the midterm review today. Hopefully you have that out and you're ready to go. I know some of you, this won't be your favorite to watch me, not on your own time, or you can skip through a lot of this, but it's really good to watch some of these things. So we'll start with this first page here. This has all of your exponent rules that we're dealing with. So first one that we looked at here was our product of powers rules. So if we're multiplying the same base, we're going to keep our base the same. I need a pen, apparently. I thought I just clicked that. Keep our base the same, and then add our exponents, so 2 to the 8th. If you wanted to solve that, you could figure out what 2 times 2 times 2 times 2 times 2, so on and so forth is. I won't worry about that too much, okay? Then we have 3 to the 6th. So don't make the mistake of multiplying those bases. That would be probably the only thing you could really mistake there. Number 3. Now we have a little bit more work where we have a coefficient. 2 times 3 is 6. And we have x to the, we'll add those exponents, 6th power. 4, we had one more variable involved. So we have 15, a to the, we're going to add those, 7th, b to the 6th after adding those. Okay. 5 can be tricky if you don't realize this is 5 divided by 10, so we would have 1/2 as our coefficient. And then x to the 5th divided by x to the 2nd, we have to divide those, so we'd have x to the 3rd, because we would subtract our exponents there. Make sure that your x doesn't look like it's in the denominator, it's just right next to the 1/2. If you had 0.5, that works as well. Okay, 6, 12 divided by 4 is 3, and then a to the 3rd divided by a to the 2nd is a to the 1st, so we don't need to write anything there. Okay. So all rules you should know, we're going to distribute into the here, so we would have 3 squared. You can write that if you want. And then x to the, we're going to multiply those, power of a power, so 8th. So we would end up with 9x to the 8th. And here, same concept, 2 to the 3rd power, a to the 15th. Okay, because we multiply those, so 8a to the 15th. All right, big thing with these, we have negative exponents, so we're going to use the reciprocal, so we would have 1 over 3 to the 5th. You could use it like that. If you solve that, you get 1 over 243. Either way would be fine. Okay, here, same thing. Our reciprocal is 1 over 6 to the 4th, or 1 over 1,296, I believe, is 6 to the 4th. Okay, so the reciprocal if you have a negative exponent. 11, we're going to multiply those coefficients, so we get 6, and then we add these. The nice thing is, if you had moved this down, you could do that too. You're still going to end up with the same thing. Negative 4 plus 7 is positive 3, or if you moved it down to the denominator, you would have x to the 7th divided by x to the 4th, which is also x to the 3rd. 12, 5 divided by 10, again, is 1/2. Okay, then we have to work with our a's, so a to the negative 7th divided by a to the 2nd, we're going to subtract, so we would end up with negative 9. So essentially we'd have a to the negative 9th. Well, we don't want that in the numerator, so we're going to end up with 1 over 2a to the 9th. So everything's then in the denominator. That's why I said be careful on 5, because this is different than that. Okay, 13, we're distributing our 0, so we would end up with just 1. And 14, a to the 0 is 1, so what's left? 8b to the 5th. Hopefully that's pretty self-explanatory. If you have questions, raise your hand. I'll pause it. We can talk about any that you need to. Okay, this is not on your review, but I did want to throw a few of these in here so that we can make sure we talk about some of this, because you will need to know how to do this for the midterm. So understanding those angle relationships and solving for them. So we have to know what they are. We have our parallel lines and a transversal here. So these would be alternate interior angles. They would be equivalent to each other. So I'm going to set them equal to each other, and then I would solve for x. So you can write these down just to have some examples. That would probably be a really smart thing to do. If I can get my pen to work. Divide by 3, and x would equal 3. Okay, here we have vertical angles. They're across from each other, so those are also equal. Five x equals 50. Divide by 5, x equals 10. Okay, these again, parallel lines, transversal, but these are on the outside of the parallel line, so this is alternate exterior angles. Those are also equivalent or equal. So do this math. Okay. And then the last one, these are supplementary, so we have to set them equal to 180. So I would have 3x minus 33 equals 180. I'm going to add 33 to both sides. So 3x equals 213. Divide by 3, and I get 71. So those would be good to write down. Maybe even write down this is alternate interior, vertical, alternate exterior, and supplementary. Okay, we'll keep moving on here. I'm not going to do these ones, but we'll talk about, this is complementary, so we would set these equal to 90, and this is, wow, I'm drawing a blank. Corresponding, goodness. Okay, so those are also equal to each other, so we would set them equal here. All right, but just for sake of time, I'm going to move forward. So hopefully you would be able to solve those as well. All right, these also are not on your midterm review, but I wanted to remind you of these as well. So let's make sure that we understand at least how to do one of these. I'm going to do 9 just because it's easy for the most room. Okay, but we need to be able to solve for the missing angle here. This should be really easy. We've done this multiple times. We're just going to take all of our angle measures and set it equal to 180, and then we're going to solve. So you should be able to do this. You're going to do 22 plus 66, which would give us 88. And then 71 plus 88 is 159. And then I'll subtract 159 from both sides. So we would get x equals 21. Okay, you need to be able to do that as well. So if you want to write down that example, great. Now we'll start to hit actually what's on your review here. We have a couple of these problems, which is important because you are going to have one on your review. So it says find the area of a rectangle with the length 4x cubed y and the width 5x to the 5th y to the 2nd. It says sketch a diagram of the rectangle. This is really helpful, okay, just so you can see the length is 4x cubed or y and the width is 5x to the 5th y to the 2nd. Area of a rectangle is just length times width. So all we're going to do is multiply 4x cubed y times 5x to the 5th y to the 2nd. So doing that, I'm going to multiply my coefficients to get 20, multiply my x's, add those exponents, x to the 8th, and y to the 3rd times y to the 2nd would be y to the 1st times y to the 2nd would be y to the 3rd. So this would be my answer. So same thing here. We're just looking for that area of a rectangle. The picture can be helpful. And if it asks you to draw the picture on the test, that's probably worth points, so make sure you do it. Area equals length times width. So we would do 9a to the 7th, b to the 3rd, times 2a to the 3rd, b to the 5th. So multiply your coefficients, 18, a to the 10th, b to the 8th. Good. Okay, moving forward. Exponential growth or decay, we're identifying the rate of change and if it's growth or decay. Remember, we're looking right here to determine if it's growth or decay. If it's greater than 1, it's growth. If it's less than 1, like down here, it's decay. Okay, then we just have to find the percent rate of change. Well, that's going to happen with whatever it is greater than 1 or whatever it is less than 1. So in this case, it would be 25% because it's 0.25 in there. We would move it over twice. In this case, we have to think about, okay, how much would if the equation asked me to do this, what did I subtract from 1 to give me 0.35? Well, you could always just take 1 minus 0.35. That gives you 0.65, and that was what would be in there, 65%, okay, because you did 1 minus that to give you what's in there. Qualitative and quantitative, hopefully you understand those differences. Here we're talking about quality. I just like to look at those base words. Here we're talking about quantity. So quality is characteristics, quantity is numbers, essentially. Some of you came and asked about working these interest formulas. All they want you to do is be able to write the formula. You probably need to know this for your midterm right here, but it kind of breaks it down for you. P is the initial amount or the principal. R is the annual interest rate, but you have to make sure that's in decimal form. T is the time in years, and N is the number of times it's compounded per year. So it'll generally tell you all that information. So if we were going to start, we would say y is equal to 500 because that's what you put in. Then 1 plus the rate, which is, if we have it in decimal form, 0.02 over however many times it's compounded. That's 2 in this case, and then to the 2t power. So the only thing you could simplify here is right here. So if we were to simplify that, we would take 0.02 divided by 2. Add that to 1, which would give us 1.01 to the 2t. So that should be right there. So the next problem is no different. Okay. This time you deposited 1,500. Your annual interest is 5, so that would be 0.05. And then it's only once a year, so that makes that really easy. So then we would have 1t, so we could simplify this as 1,500 times 1.05 to the t power. That's what would belong there. The last part is giving some examples of qualitative data and quantitative data. We'll just talk about that as a class, see what you guys put, but otherwise I think that is the end of what we had you do for the review. Your test starts Monday, so be ready to go. Have a great weekend.